Hello friends, in this video we are going to discuss about the second numerical based on AC voltage controllers. So let us read the example. An AC voltage controller supplies a power to a resistive load. So R is given, it is equal to 20 ohm. The RMS value of input voltage, that is a Vs, is equal to 220 volt. It is equal to 220 volt, 50 hertz, right? Frequency is equal to 50 hertz, right? Next, the thyristors are switched on for 30 cycles. So N is equal to 30 and off for 70 cycles. So M is equal to 70. So it is related to the integral cycle control, right? Our task is to calculate the values of RMS output voltage, input power factor, and third bit is important, that is the average and RMS values of thyristor currents. Okay, that we need to find. Okay, so let us first find RMS output voltage. Okay, so if you check the RMS output voltage, we have already derived the expression V0 RMS is equal to what? It is equal to root K into Vs. Root K into Vs. What is K? K is under root N upon M plus N, right? K is equal to under root N upon M plus N into it is a Vs. Okay, so if you check, it is under root N. N is the 30 upon M plus N. It is a 30 plus 70, that is a 100 into Vs. What is Vs? It is a 220. Okay, so if you check V0 RMS, therefore V0 RMS is equal to, yes, it is under root 30 by 100, under root 30 upon 100, okay, into 220. So it is a 120.5. It is a 120.5 volt. This is the V0 RMS we are having. Okay. Next, input power factor. Right. What is the input power factor? We already derived this expression in the previous videos. Okay. So input power factor we can write second input power factor is equal to, yes, it is equal to under root K. Okay. So it is equal to under root N upon M plus N. Okay, so is equal to under root, what is N? N is 30 divided by M plus N, that is 100. Okay, so it is like a under root 0.3, right? Under root 30 upon 100. Okay, so it is equal to 0.548. Okay, 0.548. Okay, this is nothing but input power factor, nothing but the input power factor, right? This is for the second bit. In the next third bit, they ask for the average and RMS values of the thyristor currents. Okay, so can we draw the waveform for the thyristor currents? Yes. Suppose if we draw the waveform for thyristor current IT1, okay, waveform for the thyristor T1 current, that is IT1. Yes, it will be like, suppose this is the omega T 0. Thyristor T1 will be in the on state during only positive half cycle. Okay, so for IT1 the waveform will be like this: 0 to pi, it is a non-zero; pi to 2 pi, it is a 0; 2 pi to 3 pi, it is a non-zero; 3 pi to 4 pi, it is a 0. Again the same cycle repeats. Okay, but this will be for first n cycles only, right? This will be for first n cycles, right? Next, for m cycles it will be 0, right? For next m cycles it will be like a 0 only, right? And again after next m cycles, right, next n cycles it will be again non-zero. Okay, so the, yes, the pattern will be like this for first n cycles. Next for m cycles it will be 0, right? This is for next m cycles, right? This is for next m cycle, 0, and after that again it will be same repeating. Okay, means, okay, so here now can we find this? Yes, magnitude or this expression of this waveform is like a Vs by R only, right? Vs by R only, right? Now can we find the IT1 average? Yes, we can write IT1 average. So therefore IT1 average, we can write IT1 average is equal to, yes, corresponding to m cycles, right? In for m plus n cycles, out of that m plus n, for n cycles only we are getting the pulses. Okay, so it is a n upon m plus n. Okay, into, yes, it is a 1 by 2 pi integration from 0 to pi. Okay, because for corresponding to m plus n cycles we are getting only n pulses, so it is n upon m plus n. Okay, and over the one cycle if you check whatever the pulse from 0 to 2 pi, the same is repeating from 2 pi to 4 pi, so that's why it is a 1 by 2 pi, and effective interval is only from 0 to pi. Yes, it is a vs by r, so it is a vm into sine of omega t divided by r, right, into d omega t, right. So we can simplify it as s is equal to n upon m plus n into 1 by 2 pi, okay, into, or we can take vm by r also outside. Okay, it is vm upon 2 pi r, right. Next, what is the integration of sine? Is a minus cos of omega t, limit 0 to pi, right, 0 to pi. Next, we can write it as is equal to yes n upon m plus n into vm upon 2 pi r, right, into, if we put the limit, it is like a minus of minus 1, that is a 1, and this one, so it is a 2, these two and these two will get cancelled. Okay, so now it is like n upon m plus n into vm upon pi into r, right. Next, can we put the values? Yes, n is, it is given that n is equal to 30, right, n is equal to 30, m is 70. Okay, so 30 upon 100 m plus n, so it is 100. Okay, 30 by 100 into what is vm? Vm is 220 into root 2, right, divided by pi into r. R is given, right, so r is equal to 20, we can write as into 20. So from this if we check, it is equal to, yes, therefore from this we can write it1 average is equal to, yes, it is nothing but 30 into 20 divided by 100 into 20 pi, right, is 1.49. Okay, 1.49 MP. This is the IT1 average we are having. Okay, similarly, can we find IT1 RMS? IT1 RMS is equal to what? Same, n upon m plus n into, yes, 1 by 2 pi, integration from 0 to pi. It is a Vs by r square. Okay, so it is a Vm square into sine square of omega t divided by r square into d omega t to the power 1 by 2. Right? Are you getting the point? Okay, so same way, only thing is we need to square it. So we can simplify it as is equal to, yes, is equal to, like, it is, or this can be written as, please take vm square by r square outside, so it is like under root n upon m plus n, okay, into vm upon under root 2 pi into r, right. Please be careful, this r is outside of the square root. Okay, so into integration from 0 to pi, what is the vm square sine square of omega t? Is a 1 minus cos of 2 omega t divided by 2, right, into d omega t, the power 1 by 2, right. So further we can write it as is equal to, yes, under root n upon m plus n into, yes, can we take this root to outside? Yes, so it is a vm upon root pi into 2r, okay, into, so it is a omega t minus integration of cos, it is a sine of 2 omega t divided by 2, right, limit 0 to pi to the power 1 by 2. So therefore is equal to under root n upon m plus n into vm, right, vm we are having, and write it as a vm upon root pi into 2r, okay, into, yes, it is a pi minus 0, that is a pi minus sine 2 pi sine 2 0, it is a 0 to the power 1 by 2. So this root pi and this root pi will get cancelled. Okay, so it is like, if we put the values, it will be like under root 30 upon 100 into Vm is 220 into root and divided by 2 into 20. From this we can write the final answer as under root 30 by 100 yes into 220 into divided by 4 4.26 4.26 MT. Okay, this is what IT1 RMS or RMS value of current flowing through each thyristor. Okay, so this is about the numerical number 2 related to the AC voltage controller. In the next video, we are going to discuss the third numerical related to the AC voltage controller. Thank you.